Hello students, in this video we are going to learn about probability of class 10th. Before starting exercise number 15 point, we are going to see some important terms. Let's see. First thing is random experiment. An experiment whose outcome is from the events that are completely known but whose exact outcome is unknown is called random experiment. For example, if we take tossing coin, there are two outcomes. One is heads, another one is tails. We don't know which one we are going to get exactly, whether it may be heads or tails. This one also one of the example for random experiment. Now let's see second one, sample space. Sample space nothing but all the possible outcomes are known as sample space. Same example I will take tossing coin. In tossing coin, there are two outcomes. One is heads, another one is tails. There are completely two outcomes. So these outcomes are known as sample space. Now let's see third one, event. A desired outcome of random experiment is known as an event of random experiment. Now mathematically, if you see definition of probability event, we can write like this. Probability of event is equals to favorable outcomes upon total outcomes. Probability of any event is equals to favorable outcomes upon total outcomes. Now fifth point is probability of any event lies between 0 to 1. In case if probability of any event is equal to 0, then it is called impossible event. Next point is if probability of any event exactly equal to 1, then it is called sure event. Next eighth point, P of E plus P of not E equals to 1. It may be written like this also. P of E plus P of E dash is equals to 1. Now last point is P of E is never negative. Now let's solve exercise number 15.1. Complete the following statements. Probability of an event considered as E. Probability of event not E, that means E dash, is equals to 1. For example, probability of getting heads will be equal to 1 by 2 and probability of not getting heads also equal to 1 by 2. So 1 by 2 plus 1 by 2 is equals to 2 by 2, that will be equal to 1. That's why here I wrote answer 1 in the first part. Now let's see second part. The probability of an event that cannot happen is 0. Such an event is called impossible event. Impossible event. The probability of an event that is certain to happen is 1. Such an event is called sure event. The sum of the probabilities of all the elementary events of an experiment is equal to 1. For example, if you take die, there are 6 outcomes. Probability of getting 1 is 1 by 6. Probability of getting 2 is also 1 by 6. Getting 3 also 1 by 6. Getting 4 also 1 by 6. Getting 5 also 1 by 6. Probability of getting 6 also 1 by 6. If we add all together, we will get 6 by 6. So that is equal to 1. That's why I wrote in fourth part, the sum of probabilities of all the elementary events of an experiment is 1. The probability next fifth part. The probability of an event is greater than or equal to 0 and less than or equal to 1. We can write mathematically like this. Probability of an event is greater than or equal to 0 and less than or equal to 1. This is one of the important point. Now let's see question number 2. Which of the following experiments have equally likely outcomes? And explain. Equally likely outcomes, nothing but there are equal chances for both the events. Now let's see first one. A driver attempts to start a car. The car starts or does not start. For this, answer is no, because the car starts normally only when there is some defect. The car does not start. Now let's see second one. A player attempts to shoot a basketball. She or he shoots or misses the shot. So this answer also no, because the outcome is not equally likely. Reason is outcome depends on the training of the player. Now let's see third one. A trial is made to answer true false question. The answer is right or wrong. For this answer is yes. Let's see the reason. The outcome in the trial of true or false question is either true or false. Hence, the two outcomes are equally likely. Now let's see last part. A baby is born. It is a boy or girl. This one also yes. Let's see the reason. A baby can be either boy or girl, and both the outcomes have equally likely chances. Now let's see question number 3. Why is tossing coin considered to be a fair way of deciding which team should get the ball at the beginning of football game? Because the outcomes head and tails are equally likely. Because the outcomes heads and tail are equally likely. Now let's see question number 4. Which of the following cannot be probability of any event? So option B is the right answer, because probability of any event lies between 0 and 1. If you write mathematically, P of E lies between 0 and 1. If P of E equal to 0, that is called impossible event. And if P of E equals to 1, that is called sure event. So from this, we can say that P of E is always lies between 0 and 1, and it never be negative. Now let's see question number 5. If P of E equal to 0.05, what is the probability of not E? We know that P of E plus P of E naught is equal to 1. Here given P of E equal to 0.05, that's why I am writing here 0.05 plus P of E dash is equal to 1. Therefore, P of E dash is equal to 1 minus 0.05. That will be equals to 0.95. Now let us solve question number 6. A bag contains lemon flavored candies only. Malini takes out one candy without looking into the bag. What is the probability that she takes out an orange flavored candy and a lemon flavored candy? First let us see first part. Here this bag contains only lemon flavored candies, but in first part they're asking what is the probability of getting orange flavored candy. There is no single orange flavored candy, so I am writing answer in first part. A bag contains only lemon flavored candies. Therefore, probability of an orange flavored candy is equals to 0. Here P of E is equal to 0. So this event is called impossible event. Now let's see second part. In second part they're asking probability of getting lemon flavored candy. Therefore, probability of lemon flavored candy is equals to 1 by 1, that is equal to 1. As we know, P of E equal to favorable outcomes upon total outcome. Here favorable outcomes are 1 and total outcomes are also 1. So 1 by 1 equals to 1. So this event is called sure event, because if probability of any event is equal to 1, that event is called sure event. Now let's see question number 8. A bag contains 3 red balls and 5 black balls. A ball is drawn at random from the bag. What is the probability that the ball drawn is red and not red? First let's write the given data. Number of red balls equal to 3 and given number of black balls is equal to 5 and total number of balls in the bag. Total number of balls is equal to total number of balls equal to 3 plus 5, that is equal to 8. In first part they're asking to find out the probability of getting red balls. So firstly I will write favorable outcomes. Favorable outcomes in case of red balls equal to 3, and as we know total outcomes are 8. According to formula we will write P of E is equal to FO upon TO. FO nothing but favorable outcomes, TO nothing but total outcomes, that is equal to 3 by 8. Now let's see second part. Probability of not getting red. As we know P of E plus P of E dash is equal to 1. So from this probability of getting red is P of E. That's why I'm writing a 3 by 8 plus probability of not getting red is equal to 1. That is equal to P of not red is equals to 1 minus 3 by 8. That is equals to 5 by 8. In the next video we will solve remaining questions.